Hello, so for today's video, I will be focusing on assignment 3. So before explaining the assignment at hand, I thought it would be best to briefly explain the rules of naming complex carbs. So for when naming, I think it would be best to start off with the Hayworth production, and then we can determine which is going to be the reducing and non-reducing end. Sugars that react with oxidizing agents are called reducing sugars, and the ones that do not are non-reducing sugars. With disaccharides and polysaccharides, it all depends if one or both anomeric carbons are involved in the glycosidic bond. To be exact, reducing sugars have only one anomeric carbon involved in the bond, whereas non-reducing sugars have both anomeric carbons involved in the bond. Now, returning to this assignment, it states to draw stacked forms of glucose in alpha form and mannose in beta. The glycosidic linkage will use carbon 1 of each monosaccharide, and just to name it systematically. We know that glucose is this structure, which I will draw down right now. So right here we have carbon 1, and we know that alpha indicates that the OH group will be actually axial down in carbon 1. Right here we have carbon 2, carbon 3, carbon 4, and carbon 5 right there. So this would be alpha. Glucose. Okay. We also know that this is the mannose structure, which I will also draw in a second. The only difference for this one is that the mannose is in beta. So that means that carbon 1, the OH group is going to be axial up. So that's the only difference. Okay, and this is mannose. All right, so now that we have both structures, we're just going to, start forming the glycosidic linkage. But going back to the rules, if the sugars are aldose, they will have the name pyranose. And if the sugars are ketose, then they would be called furanose. But in our case, we're going to have the name pyranose just because glucose and mannose are both aldose sugars. So that is what we are going to add. Typically the non-reducing end is first in the name, and then we drop the ose to osyl. However, we have two non-reducing sugars, so in this case the order does not matter. The first one drops the ose and changes to osyl, and the second one would end in ose if it were a reducing sugar. However, in our case, the sugar will keep the full name, but we will add the suffix SID. So as I continue on, I will form the glycosidic bond right here. And then we have the alpha ionomer right here, and we have the beta ionomer here. Awesome. So for here, we know that we have both carbon ones. So we will have 2 non-reducing sugars. So in this case, our order does not matter. So like I said, the first one will be changed to osyl, and then the second one will have the suffix side. In this case, I think I'm going to go alphabetically, so I think I'm going to start off with the with glucose. So we're going to have the full name, which is alpha, and then D, glucopyrano, because again, it's an aldose, and then we're going to add the osyl ending. An important part is that we have to show the carbons of the glycosidic linkage, and in this case it's carbon 1 to carbon 1, and then we're going to add the second ionomer of this disaccharide, and we're going to have the mannose side. Again, we're adding the pyrano because it's an aldose, and we know that for the second sugar that we have here, because the order doesn't matter, but I just decided to have mannose, we are going to add the suffix side. And here we have the full name. It's going to be alpha, and then D, glucopyranosyl, and then this is the glycosidic linkage from carbon 1 to carbon 1, Beta-D-Mannose. Thank you for following along.